it. But your perspective is, by definition, the collective, facilitating individuals and small enterprises.
First, I wanted to share this very important video.
Hussein!
We're in Chile, and we had just been at the Fab Lab conference, and we also had just been skiing. We had to go to a party. And so even when you're in a different continent, these are things that Dutch people do. Just as an introduction to everyone, hello, I'm Nadya Peek. I am at the University of Washington, where I run a research group called Machine Agency. But I did used to work at Mediamatic in this building, WASP. In fact, here you can see me. Here, if you can see my cursor, I'm sitting on the balcony here, cutting someone's hair, which is a very useful skill that I continue to use now in the pandemic because apparently, well, I don't know, it seems like everything is a bit better in Europe than it has been here, but I haven't had a haircut in more than a year. I guess I could be cutting my own hair, but right now I'm just cutting other people who live in my house's hair. And after working at Mediamatic, or Mediamatic eventually left POSEAS, and then POSEAS also got demolished, so who knows what is in this place now. I suppose all of you people who actually live in Amsterdam still. I went to MIT in Boston and did my PhD in the Center for Bits and Atoms, which is a research group focused on the intersection of physics and computer science. My advisor, Neil Gershenfeld, likes to say that computer science was the worst thing to ever happen to computers and to science. So that was the kind of anti-authoritarian streak that was around there. And that's actually where I met Joris. He came to show parts from Ultimaker and things that he was building. I met him in a Fab Lab. And so I was actually already at MIT. I had to go all the way to America to meet Joris. In, I think, New York at the first time. And as a graduate student, I was very interested in making machines, or especially using digital fabrication to make more machines. So, for example, this is the MTM Snap milling machine. And the main thing that was exciting about this milling machine was that you could make it on another milling machine, where we were imagining, similar to how Joris was imagining, it's the democratization of being able to access machines. Can we make it also even easier to scale the machines? And I think Ultimaker and us and many other digital fabrication machine groups were, in this regard, deeply influenced by RepRap, the replicating rapid prototyper. With the notion of, can we scale up the access that we have to machines by using them to replicate themselves, so using machines to build more machines. And so here is another machine that I built while I was a graduate student. This one, we were exploring multi-purpose functionality. So here, it's this pop-up briefcase that we're using as a 3D printer. This is a project from 2010 or so, but you can change the heads on it and also use it for other types of fabrication processes, like milling, also for circuit boards, or cutting stickers. And that led me to start thinking much more about the rapid prototyping of rapid prototyping, or how do you do this machine experimentation? And I don't know, sometimes Joris, when he's talking about the room size 3D printer, he likes to joke that it was just like, for the cost of a couple of screws, I turned the Ultimaker upside down and now I can make these enormous machines. And that's actually the kind of prototyping that I think is very exciting. So it's not so much like someone in the comments mentioned, have you tried resin 3D printing a video projector on here? Like, ideas are very great. Everyone has lots of ideas all of the time, but actually doing them takes time, space, and money. And so how do you actually get to the point where you're actually testing something like that out? And how do you make all of the steps up until then as easy as possible? Another question from the chat is, okay, well, I have like this machine that I'm working on, but how exactly do I make the G code to run this machine? And at least my interstitial answer to the question from the chat is, if you're working on a lathe and you're 3D printing things that are rotationally symmetric, you don't actually have to change the G code. You can just swap the X motor for the A motor. But if they're not rotationally symmetric STLs, then you have bigger problems and you might have to write your own slicer, or at least your own slicer modification. But back to my research, the thing I started becoming much more interested in is how do you make it as easy as possible to configure different kinds of automated workflows? So make it easy, not just to do things like 3D printing, but also other kinds of tasks or machines. And so together with James, we started exploring, James Coleman, who was briefly in that video, started exploring how to decompose machines into smaller parts. And not just how to decompose machines into smaller parts, but how to make those parts as replicatable as possible, or how to make it as easy as possible for other people to explore building with machines. And so we made a cardboard version of our modular machine parts, sticking with the same modular network and control system, but then making each part out of laser cut cardboard, and the design in such a way that it was very easy to experiment with all of these different kinds of shapes and ways of, figuring out automated workflows. And the major part of this making it replicatable wasn't the design, but was actually the documentation. How do you document something sufficiently so that people will actually be able to replicate it? People who don't necessarily have access to you or access to other experts who are already familiar with doing this kind of stuff. And so, what is like sufficient documentation for that to be possible, and how do you onboard more people, not just people who already are familiar with or able to do this kind of thing, but people who maybe are still trying to learn and experiment. And the cardboard machine kit was used for a while in Fab Academy, which is a class that is still taught at the WASP, for machine building. So people made lots of different types of machines, which is what I think is exciting. I think it's much more exciting to have a diversity of applications and a diversity, therefore, of machines than it is to try to build one machine that solves all problems. This is one of my favorite machines that was built with the kit. This is a Daikon Radish, and this was a machine built by people in the Fab Lab in Japan. And as you can see, they can 3D print parts. But over the course of this video, you can really see how they're prototyping their machines. So they have this incredibly adorable interface. Please peel radish now. But then you can see like, okay, it's not turning correctly, or we have like this difference between starting friction and running friction. And so they add this tailstock to the other side so that they're able to balance the cantilevered radish. And eventually, with enough iteration, they're able to make this machine, which makes these Daikon radish noodles, which, it seems like kind of a silly thing, but at the same time, this would be a very non-trivial thing to do by hand. If you wanted to create very long smears of radish, then, I don't know, you would be busy for a while. And so, yeah, I guess the interest that I have is really in how do you make it really possible to do more rapid prototyping of machines, and especially machines that maybe have crazy or diverse workflows and are replicatable by other people. And so I used to not do this, but I have increasingly leaned more on 3D printing as a machine prototyping method. This is partially because 3D printers are much better now than they used to be, so they're more reliable, and also partially because they're widely available and distributed. So this is a Toolchanging robot, or like a motion platform where you can pick up and drop off different tools using a kinematic mount. So it's similar to the briefcase machine, except that these automatically pick up and drop off the tools. And that way you can start incorporating other things into your workflow, not just one end effector, but for example, adding a microscope so that you can do inspection in between, or adding yeah, something as simple as an additional 3D print head, so you can 3D print in several colors at once, and also maybe totally different materials. It's not dissimilar to having a dual extruder, but maybe more flexible. And also developing new kinds of end effectors with which you can do even crazier things. So this is an end effector we're working on where it's like a bunch of ultrasonic actuators that we're using to pick up this small pellet in the middle, so that if you have ultra fragile things, say you wanted to 3D print with living mammalian cells, which are very fragile and kind of break when you try to extrude them, can we just pick them up and place them? And so this is sort of like a virtual container or a wall-less container in which we can hold, well, here we're holding this styrofoam pellet, but we can also hold droplets of water. We've also picked up a WASP, and then move them around and do different things with them. And that also involves not just building the hardware itself, but building the control software for it. So this is sort of the end user programming environment that we develop for making it easy for people to program the machines to do things they want without necessarily having to be an expert machine designer or programmer. This machine is a sonicating machine, for example. So it's sonicating these chemical samples. And the person using the sonicating machine doesn't necessarily want to do things like write G-code, but still wants to be able to create different combinations of chemicals and then sonicate them for different durations of time. And one thing I'm really excited about is here, if you, for example, start looking at, things like fungal spores or blood smears, can you start using computer vision to do things like diagnostics, or can we have more people developing things like diagnostic tests, especially that might be applicable in places that don't necessarily have the same kind of lab setups or other kinds of resources. And I don't know. There are other things I should show you.
Also one question from the chat, Nadya.
Oh yes, let me look at the chat.
No, it's just one. It's about the recordings running out. Do you use recycling? Is your material recyclable? Do you think about sustainability in?
I mean, I absolutely think about sustainability. I think asking if something is recyclable is a little bit of a misnomer, though, because it means that you have to explain, you have to trust that the infrastructure exists that is actually going to recycle that. So a lot of people say like, oh, PLA is biodegradable and therefore it's sustainable. But PLA is only biodegradable in very certain situations. And I know that in my city, for example, PLA gets composted, but I know that in 20 kilometers outside of my city, PLA does not get composted. And so when you think about sustainability, I think you have to think sort of bigger than just, is the material you're using recyclable or not, but what is the whole life cycle of the things that you're working with, and what are you maybe getting rid of, and what are you adding? So with some of the colony picking heads that we're putting on our robots, yes, we're like using a little bit of plastic every time we pick up a colony, and you snip off the plastic and then you pick up a new bacterial colony, because the thing that you pick up has to be sterile. And so that's wasteful, you could say. But on the other hand, the way that they currently do it is by placing a whole plastic swab in the Petri dish, and then later throwing away the whole plastic swab. So I think it's a good inclination to think about sustainability, but you do really have to think about the big picture and not just about whether or not the materials you're using are recyclable.
Thank you.
Let's see. There are other questions. Are there other questions?
Not yet. No. So everyone, don't be shy, because Nadya only has till 8 o'clock.
Yeah, it's already daylight savings time here, everybody. So it is actually an hour later than I thought it would be when I signed up to talk to you guys.
No, I'm really interested in the what you showed, the floating projects.
The floating,
because it allows for so many new applications, like you say, in certain areas, but also to work sterile, to work
This
with
one?
stuff that is, yeah, this one. I missed the link, I think, or I just didn't click through. Could you share the link?
The link to this project? Oh, it's still in development. We haven't actually released it yet. There are certain things that we haven't totally ironed out. Right now, one of the things that we're trying to do is pick up powders, and for certain powders that don't clump together very easily, like sugar, we can pick up a little bit of powder. For other powders that clump together more easily, we throw powder all over the place. Although I can link to a paper about this.
Yeah, it's very, and this kind of projects, it starts from question people have, or just because they can?
I mean, I am a researcher who focuses mainly on systems buildings. And so the way that I ask questions is, or the way that I answer questions is through building things. It's similar to yours. It's you have a question about, is something possible? And then you build a system to address it. And some of the questions that I have, I think, are a lot broader than just, is this possible? It's, is this possible? And also, is it extensible by others? Or is it tailorable by others? Or, yeah, for a lot of things, I already know that it's possible. Like, I know it's possible to project through a floor and 3D print large things. And so some of those questions are maybe not as exciting to me as, can I make it so easy to do something like that, that people actually do it? So it's a more broad question.
Yeah, but maybe to add on that, because if it's possible, I think most of the things are possible, but most of the time you need just a very big bag of money to get that. And what I really like is that at this point, you don't need that big bag of money. All the projects I do, my neighbor of 12 years old, or 14 maybe, is able to save his money for doing exactly the same things as I do. And that's really interesting. And then it also, because it's not expensive, it just maybe costs time, but it's your own time. It's also not such a big risk to just try it. You know, even if it's not useful, it's just fun. Yeah, why not? Yeah, why do you do it? Then I think a very good answer is why not? You know, that's one of the, because it costs some time.
It's a big difference also to think about how to design systems that are at a society scale possible. So let's at a society scale say, we never want to have to think about cooking, and therefore we always want to have food available at low cost every 50 meters in a city or something. And that's an approach you can take. Or you can also say, okay, well, what if people have personally the ability to grow and make food? What does that entail? And that looks extremely different than a city. You can't have people close together and also have them grow enough food for themselves. And I think for personal fabrication, or for digital fabrication being available at a smaller scale, the infrastructure, again, looks very different. It doesn't look like a factory at your house. It's different machines, different tools, different ways of prototyping. And a lot of the times, it has to do with what the workflow is that you're trying to make possible. And so the workflow might not be, let me make this as fast as possible, at least hundreds of them as fast as possible, but it might be, how do I make this exploratory, or how do I experiment within this area that I've identified?
And also, it's very difficult because most of the time I make things for myself, you know, and if I make something and it doesn't work, or maybe it works, but it only works if I clap 3 times in my hand, I turn around and then it works, then it's fine. But if I give the same or sell the same product to somebody else, it works perfectly. But every time you first have to clap 3 times in your hand, dance around, and then it works. That's not a product. And also the things I think are important, I try to solve them. But if I make a product for 10 people, I have already 10 wishes for people I have to solve. So the product is way more complex. And then I always like to make a comparison. If I build my own kitchen and one of the caches or the doors are getting a bit wonky, then I get the screwdriver and I fix it. if I make the same kitchen for Nadia, and the next week the door goes a little bit like this, she phones me angry from what is this for shitty work? So I have to check every screw for 2 or 3 times, so it gets more expensive also. And I have a lot of things in my house that I can make for myself, because I know if it breaks, I fix it.
Yeah.
You know, and I don't design it so it doesn't break. I design it so if it breaks, I can fix it.
Yeah.
And that's a completely different way of making things. And that a lot of my projects also say, okay, how proof? I don't know the English word for it, but how proof is something. And I say, okay, yeah, maybe we can make it very sturdy, but it costs so much more. We can just better make this one. If it breaks, we just make a second one, or we repair it. You know, it's a completely different way of getting into a product, or getting into a machine, or something else.
I have a very different question for both of you. I've experienced it myself as well at my work at the various buildings. We created a makerspace. The same we've done in the middle of the Vondelpark in the context of the Permanent Future Lab. We had a lot of 3D printers and other stuff, and people could walk in for free and try it out. The public libraries now have maker spaces for children, but still it's very hard to get people to come inside as to experience that it is really fun, and that they can use it for so many things. We've talked about it as well, Joris, before, because it's obviously not your mission, but when you had the Fab Labs, and I also think the Fab Lab in New York, Washington, how do you initially engage people?
Well, I think that's one of the big mistakes that people make when they set up makerspaces is that they think it's about the tools. Makerspaces are predominantly about people and community, and sustaining the community of people and how they can engage with each other. And one way you can do that is through having a space that they can pass through. So if there's like the public library, then they can pass through the space and they're familiar with it. Another thing is to have events and make sure that people feel welcome to come to the event. Or in the in makerspace in Oslo, there's a rule which I like a lot, which is as soon as somebody comes through the door, someone has to welcome them and ask them what they're there for, what they're doing. So you can't be in the space and ignore people who are walking through the door, because how else are you supposed to know about what's going on? And only after that do you start thinking about what tools are here and how do you use those tools and what's the functionality of those tools. And so, yeah, I think that a lot of times people are like, oh, you know, we're going to raise like 20,000 euros to set up a makerspace so we can buy 3D printers. And they don't think about hiring a staff member who's actually going to be there, helping people, showing them 3D printed stuff. Yeah. Or maybe a much fancier makerspace where they're like, okay, let's raise 700,000 euros and buy all this fancy equipment and still have no people there. Or they hire one technician who has to fix every single machine every time anyone touches it. And the easiest way to make sure that the machines never break is to make sure no one ever touches them. And then they're very grumpy all the time because everyone's always trying to come in and like make their job harder and break their machines. So yeah, I think the missing part of that is community building. And one way in which you can have community building is, for example, spectacle. So it's very easy to walk up to Joris because he's very tall and he has red hair and he's like carrying a 3D printer and you're like, what is this? What are you doing? Like, what's going on? And he's very friendly. And that's, I think, like an underappreciated attribute of people in the community.
Thank you very much. Are there any last questions?
Real quick, you guys. I have to
if there's something in the chat, if not, you play synthesizer, and Stein is coming up next. Build his synthesizers. Have you ever thought about building things yourself?
Oh yeah, I build all kinds of synthesizers. That's like that's a whole different thing though. I feel like music making is a very different thing than systems building. And so sometimes I feel like you need both because you have the immediacy of like pressing buttons and making noise. So I like that a lot, because every now and then, especially with electromechanical prototyping, you're like, okay, here I am in CAD, clicking buttons for a long time, and it's going to be a week or two before I know if this whole thing that I designed works.
Oh. It's a real pity you have to go. Stijn, I'm really sorry. Are you ready, Stijn?
Oh yeah, I can start.
I'm really sorry that Nadya has to miss your story about.
We'll talk synthesizers sometime later. Synthesizer
sounds good.
building is a whole different beast as well. So
yes,
in the future.
Yes.